Okay, good day everyone. You are welcome to my channel. This is Technical Drawing Made Easy. If you are joining this channel for the first time, please do well to like, subscribe, and turn on the notification button for upcoming videos that I will be dropping. Today we'll be looking at Waec question 2021, Technical Drawing Paper 1. Paper 1 is always objective test. You'll be given 40 questions. Option A to D, and you have to use 1 hour, 40 questions for 40 marks. This is 20% of the exam. Paper 1 is always 20% of the exam when you calculate it. The total mark is for 200 marks. Then this paper gives you 20 marks. So if you calculate it as 20%. So let's go on. Section A has 30 questions and you have to answer all the questions. Please do your best to answer all the questions in this section. It's very important. Do your best to answer all the questions in this section. So number 1 says, one example of a regular polygon. The stress is on regular. All 2D shapes, which we call the plane shapes, are referred to as a polygon. All the plane shapes are referred to as a polygon. So if you look at all the shapes, we are given a scaling triangle. First, you ask yourself, what is a scaling triangle? A scaling triangle is a triangle whereby all the sides are not equal. All the sides are not equal to each other. So this side is not equal to this side, is not equal to this side. Do you get it now? So, and a square looks like this. A square is a shape whereby all the sides and all the angles are equal. A kite looks like this. A kite's adjacent sides are equal to each other. Then a rectangle looks like this. A rectangle, opposite sides are equal to each other like this. So the word is on regular. So you need to ask yourself, what is a regular shape? Anywhere you are asked. A regular shape is a shape whereby all the sides are equal to each other. All the sides, equal sides. All the sides are equal to each other. So when you hear a regular shape, all the sides should be equal to each other. So which out of these 4 shapes, which one is the sides are equal? That's what? That's a square. So take note of that. I'm explaining this in case I know most of you will think this is a cheap question, but at the same time, we have students that fail questions like this. Most people don't understand the word regular, what it actually means. It means when a shape have all the sides to be equal. So we go to question 2 and 3. The sketch in figure 1 shows a technique for dividing line PQ. Use it to answer question 2 and 3. Division of line method. This is what is being tested here. So we have line PQ. The number 2 question says the value of x ratio y. That means the value of x. What's the value of y? Is what? Let's count. For x, the starting point here is 0. We have 1, 2, and 3. X stops here. Do you see that? Yes, that's 3. Let's count for y. 1, 2, 3, 4, 5. Can you see that now? So this is the end of y. So what is the ratio there? 3:5. So you pick A. If x is 6, that means we have 3 divisions. 3 divisions for x. And they tell us it is what? That 3 division is 6 centimeter. What will 1 division be? Do you get it now? You need to calculate that. What will 1 division be? So you say 1 division is what? 6 centimeter over 3. That will give us what? 2 centimeters. So 1 division is 2 centimeters. What is the length of PQ? The overall length. A lot of students make mistake and only calculate for y, the distance of y. Do you get it now? Since they found that, or they only calculate for x, please take note. They ask you the whole length of PQ. So how many divisions do we have from P to Q? We have 1, 2, 3, 4, 5, 6, 7, 8. So if one division is 2 centimeters, what will be for 8 is just to multiply 2 by 8, or you say 2, 4, 6, 8, 10, 12, 14, 16. So the answer is what? 16 centimeter. That is D. So let's move on. Question 4. Good. Question 4, it says figure 2 shows a diagonal scale. What you are looking at is a diagonal scale for figure 2. Use it to answer question 4 and 5. So we are using this scale to answer question 4 and 5. Good. The length X, you can see where X is. The length X is dash. The diagonal scale, like I keep telling you from my videos, has what we call the subscale and the main scale. Do you get it now? That's the main scale. Here the main scale, I told you this point is 0. You can see they indicated it here. 0. The main scale is always to the right, while the subscale is to the left. So you have to reach the main scale first. So for X, where does the where does it stop for the main scale? That is 1. So it's going to be what? 1.00. So this is the diagonal scale. Then for the subscale, you have to check the horizontal subscale followed by the vertical subscale. So for the horizontal first scale, we need to count. What is it? 1, 2. Can you see that now? So that will be what? 0.2. 1 decimal place. Then for the vertical scale, is going to be 2 decimal place. So let's count. 1, 2. Can you see that now? So that is also 0.02. Do you get it now? So we are going to add everything together to get our scale. So we have 2.1. So the length there is 1.22 millimeters. 1.22 millimeters. You can see the unit here. So we go to question number 5. The length Y is what? The same thing. The length Y is what? Let's clean the one for X and find the one for Y. Okay, let's go back. For Y, where to the right, where does it stop? The main scale is what? 2.00. Can you see that? Then for Y, let's count for the horizontal scale. Where does it get to? 1, 2, 3, 4, 5, 6, 7. Can you see that? 7. That will be 0.7. Then for the vertical scale, we have 1, 2, 3, 4, 5. That is 5. That will be 0.05. If we have everything together, we have 2.75 millimeters. That is also what? That is also option B. Go to question number 6. Figure 3 shows a triangle drawn between 2 parallel lines, QR and ST. 2 parallel lines. 2 parallel lines are 2 lines that have equal distance between them and they can't meet. So this sign you are seeing here, this arrow, tells you they are parallel lines, even when they are not drawn as parallel. So just take note of that. Use it to answer question 6 and 8. So the value of angle Y is dash. This place you need to find what the angle is. So even before answering the question, if I were you, you work on the diagram you are given first. Look at this angle SLM. They tell us it is 110. So what is going to be on the other side? It is angle on a straight line. So if you take away 180 from 110, angle on a straight line will have what? 70 degrees. So this place will be what? 70. So I can also look for this angle. Since angle in a triangle sum up to 180 degrees. So if I add 30 to 70, that will give me 100. Is that not? So I can take away 180, the sum of angle in a triangle, from 30 degrees from 70 degrees. Do you see it now? That will give me what? What will give me here is what? 80 degrees. Then I can look for X. Since 80 and X, they are on the same line, that is still angle on a straight line. That will be 180 degrees minus 100. Do you get it now? Sorry, not minus 100, minus 80. Angle on a straight line. So my mind automatically tells me that is what? 100. So I can find y. So if 80 is on this side and y is on the other side, your thought is as good as mine. What do you think that value would be? It's going to be what? It is going to be 80 also. It's going to be 80 degrees. So that is called adjacent angles in mathematics. So that will be value is going to be what? 80. Then they ask us that angle x can be described as what? Remember what our value of angle x is? It is what? 100 degrees. So they said, could it be an acute angle? No. Acute angle are angle less than 90 degrees. Is it a complementary angle to y? No. It's not a complementary angle to y. Complementary is when we sum of two angles and their sum is 90 degrees. So if we sum up x and y, can you see that now? They can't give us what? They can't give us 90. Then is it a reflex angle? No. Reflex angle is what? Is greater than 180 degree. That's a reflex angle, but less than 360 degree. Do you get it now? And that angle x is 100. So it's not up to 180. So they said D, a supplementary angle to y. Yes, is a supplementary angle to y. Like I told you for complementary. Complementary is when I sum the two angles together. Look at what I draw for you. When I have an angle like this, and I have another line in between it like this, good. If I have the two like this, good. And I have an angle here, let's say x, I have another angle here, y. And when I sum it up, and they are equal to what? 90 degrees as shown. That is complementary angle. But this supplementary now is when I have an angle. Look at it over here. When I have an angle on a straight line like this, let me change the color. Then I have a line like this, and this angle and this angle are on it like this, A and B. When I sum it up together like this, they give me what? 180 degrees. Can you see it now? So look at angle X. Can you see that now? Look at angle X. Do you see it now? Angle X is what? Is supplementary to what? Angle Y. Because if I add 80 to 100, it will give me what? 180. So automatically they are what? Supplementary angles. Is that clear now? So the answer is D to number 7. Let's go to number 8. Triangle LMN. Triangle LMN. Let me clean off all this so we can see that shape very well. Thank you. So we have asked that triangle LMN is an example of what? Let's look at the triangle LMN. LMN is what? Is it an isosceles triangle? Is it an equilateral triangle? Is it a right angle triangle? Is it a scaling triangle? Let's write back the values that we got. This place we got 70 and this place we got 80. So how do you know what type of triangle is it? It is the angles you use to know. If it is a isosceles triangle, all the angles should not be equal to each other. Just like we have it here, 30, 70, 80. Do you get it now? If it is isosceles, the two base angles, do you get it now? The two base angles, 70 and 80, they should be equal to each other. We should have two equal base angles. If it is equilateral triangle, the three angles should be equal to each other, which is in most cases should be 60 degrees. If it is right angle triangle, one of the angle, it should be what? Should be 90 degrees. Do you understand now? So, in case they ask you a question on that. So, the answer here is what? Is scaling triangle. Why? We have angle 30, angle 70, and angle 80. All the angles are not equal to each other. So they are not, they are a scaling triangle. Is that taken? Good. Number 9 says, trapezium is a quadrilateral. Good. With dash, is it 4 equal sides? Only one right angle, only one pair of parallel sides, 2 pair of parallel sides. What is the answer? Let's draw a trapezium. Trapezium could look like this. Trapezium, like this. Do you see that? Or like this. Do you see that now? What should be in a trapezium is that you should have only one pair of parallel sides. Do you see that now? Only one parallel. So C is the answer. It is not A because all the sides should not be equal to each other. If they are equal to each other, it's going to make it a square or a rhombus. If it is having 2 pairs of parallel sides, it automatically turns to what? A parallelogram. That is the definition of a parallelogram. 2 pairs of parallel sides. Number 10. The regular polygon with an interior angle of 144 degrees is dashed. The regular polygon with an interior angle of 144 degrees is dash. A, heptagon, B, octagon, C, decagon, and D, dodecagon. This is calculation. This is calculation. Like I told you in my videos, you can't do without mathematics in technical drawing. This is what we call cross-curricular content in your curriculum. Do you understand? So it's very important that as a technical drawing, you are very good with mathematics. So what is the formula for finding the interior angle? They call it each interior angle of a regular polygon. Do you get it now? So let me give you the formula. Formula for finding the interior angle of a regular polygon is equal to, now, n minus 2 into bracket 180 degree. If you are looking for the what? The sum of the interior angle, you are going to use this method. But when they are asking you for one of the interior angle, you are going to divide it by what? By n. Do you get it now? So if they are asking you for the sum of the interior angle of a regular polygon, you are to use n minus 2 into bracket 180. But in this case, when they are asking you for each one of it, do you get it now? You have to divide that formula by n. So this is the formula for finding each interior angle of a regular polygon. Do you get it now? And in this case, we are given one of it, which is an interior angle of what? 144. So that I'll put it as what? As r. Then equal to, we are looking for n. Do you remember that? So I have n minus 2 into bracket 180 degree all over n. Do you see that now? Good. So what's the next step? This is mathematics. I told you earlier on. Cross multiply. So in this place, I will have what? I will have 180 multiplied by n. That will give me what? 180n minus 2 times 180. That will give me what? 360 degree. Can you see that now? Equal to 144 times n. That will give me 144n. Can you see that now? So let's collect like times. That will give me 180n minus 144n minus 144n. Take 360 to the other side, it will become 360 degree. The minus will change to plus. Do you get it now? So 180n minus 144n will give us what? 36n equals to what? 360 degree. Then what do we do? Divide by what? 360. Divide both sides by 360. The coefficient of n. 360 we cancel 360. We are left with n equals to what? 360 degree divided by 36. That will give me what? 10. So 10 is the number of sides. So you ask yourself, which shape has 10 sides here? Let's see. A, we are given heptagon. That is what? 7 sides. B, octagon, that is 8 side. Decagon, how many sides is that? Can you guess that? Okay, good. 10. Then the decagon is what? Is 12. So what gives us the answer? The answer is what? Is C. If you are not familiar with this formula, please, I would like you to write it down, memorize it, and you are good to go. Let's move on. We'll go to number 11. Number 11. Number 11, we are given this figure. Figure 4 shows a type of construction. Use it to answer questions 11 and 12. Look at this construction. Can you tell us what construction is meant for? What construction is it meant for? I hope you've done this before. So let's go to that. I already know the construction because I'm familiar with it. So let me look at the question. Number 11, the construction is meant for dash. Can you see? They will definitely ask you what the question is meant for. A, finding the center of a circle with given circumference. B, finding the perimeter of a circle with given diameter. C, determining the perimeter of a semicircle. D, determining the diameter of a circle with a given circumference. Let me go back to the construction so you can see it again. So what do you think the construction is meant for from A to B? The answer is D. The answer is D. It is used for determining the diameter of a circle with given circumference. When they give you the circumference as a line, remember, circumference of a circle should be what? Should be round. When you draw a circle, I keep telling my students, when you draw a circle like this, the circle is not the line you drew. It's not this green part I drew on the screen. It is the space inside that circle that is the circle. This line I drew is the circumference. Now imagine that they gave you the line as a straight line like this. This is now, that's exactly what is given here. This line you are looking at is the circumference of the circle given. So they will give you the length of the circumference. Then they will ask you to look for the what? Diameter. That is what this construction is meant for. Is that clear now? So the answer is what? The answer is D. So then I ask you, number 12, line ST is the what? Like I told you, line ST is the what? A, diameter of the circle. B, radius of the circle. C, 1/3 of the circle circumference. 2/3 of the circle circumference. The answer is what? A. I explained to you. The construction is you are given the circumference as a line. Then you are asked to find the diameter of the circle to be able to draw the circle. So that is the answer. We'll move to number 13. Number 13 has a diagram too. The sketch in figure 5 shows two tangents, PR and RS, to a given circle with center O. Use it to answer question 13 and 14. Good. I explained this in one of my videos. If you have seen it, you'll be able to relate. What is really happening here? When I see a diagram as an architect or an engineer, a technical drawing student, what comes to my mind is for me to analyze the diagram first before even looking at the question. The question really don't bother me. What bothers me is the diagram. I need to understand the diagram. That gives me joy. I need to understand the diagram and know what's happening before I look at the question. Once I understand the diagram, I'll be able to answer the question. So what is happening here? We have talked about it before. This is an ascribed, it's a type of circle. An ascribed circle. You see that? So this triangle is drawn and the circle is drawn outside, touching the triangle at a point. So it's an ascribed triangle, circle. Part one of the type of a circle. So let's go to the question. Line OQ is a dash. Line OQ, where is OQ? Look at it. From the center of the circle to this point, which is Q. So for you to know what that line is, you need to know what line PR is. Look at this line, PR. Can you see? Good. That line PR is a what? That line PR, this is how to write a line. Is a what? Is a tangent. What is a tangent? A tangent is a line that touches a circle at a point and it forms 90 degrees with the center of the circle. Do you get it now? So they are now asking us, this line that is drawn from the center of the circle to that tangent, what is it? The answer is what? Is a normal. Is a normal. That line draws from the center to the tangent is called a normal. That normal is also equal to the radius of the circle. Also equals to the radius of the circle. So they intentionally did not put radius there because they know you know it's the radius as a part of the circle. But in relation to the tangent, it is known as the normal of the tangent and it is at right angle. So you can see the next question is asking you that angle PQO is what? Can you see? PQO, this angle. I told you the angle is always at the center, at the middle letter, like this, Q. So they're asking you what angle is formed at Q, PQO. Can you see that now? Is a what? Is a right angle. I explained to you. The center will form a right angle to the tangent. Let's move to question number 15. We are given a diagram too. Which of the following satisfies the similar triangle shown in figure 6? Similar triangle shown in figure 6. We should have done similar figures. Similar figures. So let's look at the two. Before looking at this I told you, understand the diagram first. So let us look at EF. Side EF is equal to what side on the other similar triangle? You can see. Just look at that. See this marking. It's the marking you used to know that they are equal. So it's equal to what? HJ. Can you see? They have the same marking. What of side FG? It has two marking on it. So FG is equal to, look at the second one, JK is equal to JK. They're having the same marking. Then if you look at EG, is equal to what? HK. They have no marking on them. Can you see it now? So I can look at my options. A says EF over EG equals to HJ over JK. Is that right? No, it's not right. Then EF equals to HJ, yes. FG equals to JK, that is right. Can you see that now? It's just like putting an arrow here, a line here. Can you see it now? That's equal. Let's check others. EF equals to AJ, FG equals to HK, no. FG equals to JK, yes. GE equals to HJ, no. That's not correct. Do you get it now? So B is the what? Is the answer. Please go over it again. I believe the explanation is clear. Let's move to number 16. The locus of a point which has a constant ratio of unity. Before I finish reading the question, I know the answer already. Because of this mention of unity. So its perpendicular distance from the directrix is dash. Can you see that now? So this is the locus of a point. So you ask yourself, what are those curves that are formed on a conic section? So I do tell my students. So the answer here, since they say unity, unity is what? Is 1. Unity means 1. Anywhere you see it, it means stands for 1. So they are asking us what is the locus of the point which has a constant ratio. All this grammar is simply directing you to what? Eccentricity is equal to what? 1. So if you look at this, epicycloid and hypocycloid, that's not their definition. They have nothing related to that. We are left with hyperbola and parabola. Hyperbola eccentricity is what? Is greater than 1. Parabola is the answer. When we have parabola, eccentricity is what equals to what? 1. So when the locus of a point which has a constant ratio of unity, it is parabola. We move to question 17. Figure 7 shows a type of locus. Good. They keep asking us locus. Use it to answer question 17 and 18. Question 17 and 18. So let's look at the figure. Without even looking at the question, what shape is this? What curve is this? You should have answered that yourself. So 17 is asking us the same question. What type of locus is this? It's very simple. It is what? It is an ellipse. I'm sure you know that too already. A parabola looks like this. Can you see the curve? Good. A parabola is going to look like that. Hyperbola is going to be slimmer like this, and most times on both sides. This that. A circle, everybody knows how a circle looks. Do you get it now? Good. So let's go to 18. The line labeled X is what? Good. This line labeled S is called the directory. That's the name it is called. Good. Other lines there, let's look at them for another time. This line you are looking at, this one at the center, the shorter one, that vertical one at the center, that vertical center line is called the minor axis because it's smaller. Do you get it now? Good. That longer one that is there at the middle is called the major axis because it's what? It's longer. Do you get it now? Then span. Span is not used here. Span is talking about how wide a drawing is. Do you get it now? They use it mostly when we are talking about parabola. So let's go to question 19. Oh, I like this question. The isometric view of the object represented orthographically in figure 8 is good. They gave us the orthographic projection. Who can tell us what type of orthographic projection is this? It's a third angle orthographic projection. You can see the front elevation is down, the plan is up, then we have the end elevation by the right. So when we look at it, which will be the answer? Is it A, B, C? The answer here is, look at it very well. The answer is C. Most of you might be tempted to pick A, but please look at the line. You can see that for A, there is no line here. Let me put it. Do you see that now? And the line exists here. Do you see it? From the front side. Then from the plan, then there is no line here. And the line exists on the front elevation here. So you need to take a good look at it. So if you look at B, the same thing happened. What happened at B is that there is no line on that part. Then D, again, there is no line on that part. So, but that object really has lines on both points. So C is what? The answer. When you are dealing with isometric orthographic, you need to look at your shape very well because a little line can change everything. We'll go to the next question. Use the pictorial view of the object shown in figure 9 to answer question 20 and 21. So let's look at what the question is. Number 20. The correct view in the direction of arrow X, S is dash. So let's look at that object again. Okay, so without even looking at the option, please you should be able to sketch this yourself without looking at it. So they said arrow S. That means you are looking from this side. Do you get it now? So please, what do I see when I look from this side? Please look at this place. Good. That place I'm shading. Good. So draw it out. That's a rectangle like this when you are looking at it. Good. Then at the bottom, I'll be having what? I'll be having this. Right? I'll be having this. Is that not? Good. But there is an hidden part there. Look at this part. It's hidden. Do you get it now? So look at this. There will be an hidden part on that. And you show that with what? Short dashes. So that's how that view is going to look like. Let's look at the option that looks exactly like that. Can you see? Yes, the answer is what? The answer is C. That's exactly what we drew earlier on. A will have been the answer, but there is no hidden detail shown. Do you get it now? So that's why I said a single line can change everything. So C is the answer. You must show the hidden details. 21 says the correct view in the direction of arrow T is dash. So let's go and look at arrow T. You should be able to sketch that too yourself, even without looking at the option. You should be able to exercise your brain in the exam. Arrow T, when we look at arrow T, look at it. I'm going to see this place. They're asking me for the side elevation. Then I'm going to see this place. Is that not? When I look at it from the side. Any hidden part? Any hidden part? Ask yourself. I don't think there is any hidden part for this. So I will have this like this. Good. And I'll also have this like this. Please always ask yourself if there is going to be any hidden details. So if I go and check the options for 21, let's look at it. Oh, which one is the answer? The answer is C also. It's D, D, D. Please take note. Can you see now? You have to be very careful. A line can change everything. It is what? It is D. Can you see my own? It is D. So if you look at C, C will have been the answer, but take proper note. You will see that a line crossed the leg. And if you look at on the drawing, there was no line crossing the leg on the drawing. So you need to take note of that. So let's move on to number 22. Figure 10 shows a line in space between horizontal plane HP and vertical plane VP. So you can see the plane, right? Good. Figure 10. Line KG. This is the line. This is the main line. Other things you are seeing there is projection. Do you get it now? Line KG is what? Is it parallel to both HP and VP? No, it's not parallel. It's only parallel to VP. If you look at it, then B says parallel to HP and at angle to HP. Yes. C perpendicular to VP and parallel to HP. No. D perpendicular to both VP and HP. No. So automatically, the word perpendicular, when it is used, makes it wrong for this question. What does perpendicular mean? Perpendicular means it is at right angle. It is at right angle. Perpendicular. It means what? When it is at right angle, and that is what? 90 degrees. So if you look at this drawing, is there any way of that plane, of that line? Does it form right angle at any point? No. So the moment they measure perpendicular in C and D, you know it is totally what? Totally wrong. So it lies between A and what? And B. And if you look at VP, it is parallel to VP. You can see they draw it and it extends to what? VP. And you can even see they put equal lines on them. But if you look at it coming down to HP, it is at an angle to HP. It's just like if I draw a line here now. Do you see that line? Yes. Can you see this angle here? Yes. So that's what tells you that that line is at an angle to HP. So the answer is what? The answer is 22. Do you understand the drawing now? In case you are given another question in that form, just analyze it like that. 23. The true length of line A1E in figure, this is the A1E. This is the line. That's the line they are dealing with. In figure 11 is dash. This method is a revolution method. Let me write it. Revolution method. We have triangulation method, we have revolution method. If you are not familiar with revolution method, this is a reminder for you to go and learn revolution method. Watch my videos, you will see the method in one of my videos. This is a revolution method of finding the true length of a line in space. This question is also on line in space. So when this line is revolved, we use that revolving to find the true length. So they're asking us that which line out of all these lines is going to be the true length. Look at it. That line is being revolved from point E down to point what? Point F1. But that true length will not be found there. The true length will be found at this point F. Do you get it now? So that true length is going to come from, the length is going to be from A to what? To F. Do you get it now? That's where the true length is formed. We only projected E to E1. We projected A1 to A down. Do you get it now? Then we found the true length at AF. So the answer is what? Do you know the answer? Is C. AF. So that's the true length. Go and revise your revolution method for finding the true length of a line in space. We'll go to question 24. The sketch in figure 12 shows two views of a hollow square pipe. Use it to answer question 24 and 25. So I love to sketch this. When I see a challenge like this, it's drawn in orthographic projection, convert it to isometric. It's going to look this way. It's going to look this way. Yeah. Going to look this way. It's hollow. That means there is a hole in it. So remember to put that so you don't confuse yourself. So they tell me that the correct view, so you can see the plan, you can see the plan. Looking at it from the top, that's what I just drew. Then the front view, that's what you have there. So they are telling me that the correct view, when I cut along plane XS, where is SS? Good. So they are telling me that when I cut, let me put it there, SS is going to be on what? On this side. So if I put it here, let me make this the front elevation, this side, the front elevation. So if I put this as the front elevation, if I cut it here, what do you think the view will look like? If I cut it here, right? I cut it across here, cut it down here. Do you see it now? So the cutting will take place along that path. That is XS. This is X. This is what? X. So if I cut it along that path, what do you think I will see there? Let me see if I can work on it. If you cut it along that path, you will see that, remember what I explained, it's only the material area that will cut. It's only the material area that will cut. So what will I see? I will see this point, like this, and I will also see this point. Then there will be a space between it for that hole. So which one looks like it? Which one looks like it? It is now question what? Now option what? Is it A? No, it will not be A. It will be what? It will be B. It will be option B. Why is it not A? Look at it very well. Why is it not A? These short dashes they put in A is not meant to be short dashes. You are going to be seeing that part. So if you cut that object, you will be seeing this part, which is the material. It's going to form like this. So you are going to be sectioning it like this. Do you get it now? If you cut this part, you are going to see like this, which is going to be sectioned like this. Do you get it now? Then the line in front here, you are going to be seeing it up and down here. That's how it is going to be. So it's just for you to be able to see the cut at that point. Let's go to 25. The correct view along YY. Good. The XS cut it longitudinally. Then YY is cutting it at the middle horizontally. So if we cut this object, look at it. If I put a cut on this object, at this point, what will I see? It's very simple. You are going to see the same shape you see at the top. Just like that. It's just like cutting a cylinder. You are going to see the same shape you see at the top. But this time around, it has to be hashed to show that what? To show that it is cut. So let's look at the one that I have there. That is what? That is option A. Can you see that now? You are going to see the plan. Exactly the plan. Can you see it? But you show the symbol that it is what? It is hashed. B cannot see the answer because they hash both the material and the O together, and I told you that is wrong. C is not going to be the answer because they hash the inside, which we are not supposed to hash, and leave the material alone. D is not going to be the answer because they use the short dashes to show that part, which is very, very wrong. 26. The surface development of a hollow square prism is in the shape of a, can you see? The same question they gave us up here, hollow square prism, that they gave us up here that I drew. They are now telling us that when we draw the surface development of the prism, what shape will it give us? Can you see that now? What shape? Is it going to be a kite? Is it going to be a triangle? Is it going to be a trapezium? Is it going to be a rectangle? Look at exactly what I drew for you here. And look at the front view. What shape do you think you are going to have? It's as simple as that. You don't need more explanation on that. It's just for you to understand surface development and also be able to use your thinking. The answer is what? It's a rectangle. It's a rectangle. So we'll go to number 27. Also on surface development. The surface development of a frustum of a hollow square pyramid shown in figure 13 is dash. So let me explain one after the other. Everybody know what surface development is. Surface development is simply opening up a shape for us to see the layout. Laying out a shape on a flat surface. So frustum is what? Anytime we cut a shape, for example, a cone, do you see it? If the plane cuts it perpendicular to the base like this, do you get it? What we have is going to be what? It's going to be called a frustum. So it's just like removing the top. It's like removing the top off, like this. What we have left is called a frustum. What about if the shape is not parallel to the base? For example, if we have a cone like this and we cut it like this, it's not parallel to the base. What do we have? What we are going to be having is going to be like this. That is what is called a truncated shape. So whatever the shape is, for example, this is a truncated cone, and I just thought to explain that. Do you get it now? Then this part, they are telling us that it is what? It is hollow and it is a pyramid. Can you see that now? It is hollow. Hollow means it has O in it. So that's the reason for this shape here. Can you see that now? They are telling us that it is hollow. That means this shape I showed you, there is a O that passed through. It is not entirely on the object. And a pyramid, tells you that it has a point at the top here. Do you get it now? It does not have a uniform cross section. Do you get it now? So all those explanation is needed when you want to answer this question or for your future questions that you need to answer. So let's look at what will be the surface development. What will it look like? The surface development is going to simply be what? It is going to be B. You are going to use what? What method will you be using for this? We are going to use a radial line method. Radial line method is used for pyramids. That's the method that will be used. And when you use it, you are going to have a straight line from one point to another. Do you get it now? Like this. You are going to have a straight line like that. This is going to be short dashes. Straight line, straight line, straight line, straight line like that. Straight line, short dashes here, straight line here, straight line. Do you get it now? So this is what you are going to be having. If it is a cone, not a square pyramid, if it is a cone, it will be D. But it's not a cone, so it's going to be what? It's going to be B. You have to look at it very, very well. Very, very well. That's taken now. Good. So you understand why it is that option B. 28. Which of the following views shows the line of intersection of two equal pipes shown in figure 14? Anytime we have equal pipes, either a square pipe, either a cylindrical pipe, anytime we have equal pipe, please always understand that the adjoining is going to be what? It's going to be a straight edge like this, as you have seen in B, C, and D. Also, if it is an equal pipe, it's going to start and end from this edge like this to the center here. Do you see that now? This is where I pointed. It must get to the center. So if you look at this shape given, the plan given here is wrong. Waec intentionally gave you this question to confuse you. But you have to read the question. They said two equal square pipes. So the drawing should have extended to this point like this and extended back to the point like this because they are equal pipes. Do you get it now? So it is option B without wasting much of our time. So let's go to question 29. This is the easiest question for me. Man, looking at it. Let's read the question. The total angle around a point is, even if you ask a child in primary school, they will tell you this. The total angle around a point, what is that angle? It is 360 degrees. So when you have a point like this, the angle around it is what? Is 360 degrees. We call it revolution angle. Last question for section A. The sketch in figure 15 shows the symbol of dash. The sketch in figure 15 shows the symbol of dash. The answer here is what? Remember, isometric drawing does not have a symbol to be shown. Oblique drawing does not have a symbol. What have symbol is orthographic projection. Anytime we draw orthographic projection, we put the symbol to tell if it is first angle we are drawing or second angle we are drawing. Are you listening now? So also the symbol is that of a trapezium and a concentric circle. What is a concentric circle? In case you don't know, a circle, two circles now, two or more circles having the same center. That's a concentric circle. That's the circle you are looking at. Those are the circles you are looking at. Then a trapezium is what follows it. So which symbol is this? It's simply a symbol for third angle orthographic projection. Simply a symbol for third angle projection. If the trapezium comes before the concentric circle, it is going to be first angle orthographic projection. But if the concentric circle comes before the trapezium, it is what? The third angle orthographic projection. So we come to the end of section A. Let's move quickly to section B, part 1. Part 1, for section B, you have to answer part 1, building drawing, or you answer part 2, mechanical drawing. But I would advise you it's best for you to know the two options. It's best for you to know the two options to help you in determining the right answer. Figure 16 shows a type of staircase. Use it to answer question 31 and 32. Use it to answer question 31 and 32. The type of stairs shown on the sketch is A. Spiral stairs, B. Quarter turn, C. Open well, and D. Straight flight stairs. The answer here is what? Is straight flight stairs. You can see it is in one straight flight. No explanation. That's the explanation. Spiral stairs is going to what? It's going to have a pillar like this, and the stairs is going to go around it like this. That's the plan. Quarter turn. It's definitely going to have a turn, quarter, and it's going to turn to one side. This there is no turn. Open well stairs is going to have a long amount of stairs for high-rise building, and you're going to see an open part in it. Let's go to question 32. The part labeled T, you can see, is what? The part labeled T is what? Is the hand railing. The hand rail. The hand rail. Can show to 33. Which of the following building material symbol represents hardcore? You should know your representation, your conversion. The answer is what? The answer is A. 34. The sketch in figure 17 shows a pictorial view of a building. Use it to answer question 34 and 35. Use it to answer question 34 and 35. So the correct view in the direction of our Y is okay. So when we are looking at this building from this arrow here, so what are we going to see? One, you are going to see the roof. So you can see the squares on top of the drawing. Then you are going to see a rectangle on the left and a rectangle on the right. Can you see that now? So you are also going to see this place, rectangle. You're also going to see this place, rectangle. You're also going to see this place, rectangle. Do you get it now? Then you are going to see this place, rectangle. Can you see that now? So which answer is that? The option is what? Is C. Can you see it now? So you are not going to see this place. Let me show you. So don't be confused. You are not going to see this place. That is why B cannot be the answer. Also, D cannot be the answer because of this. Yeah, can you see that now? Then the center does not extend down here. So this rectangle make it wrong. So we are not going to see all those parts. Do you understand now? So that is the reason why that is the answer. 35. The type of roof on the building is what? Look at this type of roof. It is what? It is gable roof. It is gable roof. That's what we call the gable or pitched roof. 35. 36 now. The type of building tool shown in figure 18 is what? The answer is D. It is baluster. If you have not seen this tool before, this is what we call a baluster for building. It is a building tool that we use to remove hard, unwanted part from a building. If you are building maybe a block or something and you need to chip up a part of the block, or you need to scrape off some part, we use this baluster. So question 37, the part of the foundation that prevents the penetration of moisture into a building is what? The answer is B, damp-proof membrane. The answer is B. That's the answer. The damp-proof membrane, that's the function of the damp-proof membrane. It prevents the penetration of moisture coming from the ground into the building. So we'll go to question 38. The sketch in figure 19 shows a part of the cross-section of a roof. Use it to answer question 38 to 40. Use it to answer question 38 to 40. So the part labeled E is the what? The part labeled E is the fascia board. It's as simple as that. It's the fascia board. The part labeled G is the what? A, strut. It's as simple as that. Lastly, for building drawing, they said the part labeled F is what? Is the wall plate. Is the wall plate, as you can see, is the wall plate. Please, it's very important for you to know the parts of your building, especially the roof, the parts of your building. So, as we can see, we have E to be the fascia board, we have G to be the strut, we have F to be the what? To be the wall plate in this building. So we come to the end of building drawing. We come to the end of building drawing. Okay, so let's go to part 2, mechanical drawing. So 31, the correct dimensioning of the spot face hole labeled Y in figure 20 is, look at the labeled part, which is Y. So it's about spot face hole. So there is a hole here on that concentric circle. So that place is up. So what they're asking about dimensioning. Dimensioning is very important. So you have to know how every element in mechanical object is being dimensioned. So if you look at this, going to O is very easy. If you look at it, the dimension for dimensioning a circle is what? The convention is a file like this, and it must always be in front of the dimension. For example, 12. So the answer here is what? Is D. The answer is D. So if you look at this place, file is in front of 12 and it's also in front of what? 25. It's always in front of 12 and it's also in front of 25. But if you look at other options, can you see it now? Is at the back of 25 here. So that is wrong. That's what makes that option wrong. It's at the back of 12 here. Can you see that now? That's why it is wrong. At option C, it's at the back of 12 and yes, it's at the back of 12. Can you see that now? So it's also at the back of 25 in the other option. I'm just saying it. So that's why all those options are wrong. So the file convention for a circle should be in front of the number, which is the dimension. 32. The type of rivet pin shown in figure 21 is dash. Is it snap head rivet pin? Is it flat head rivet pin? Is it mushroom head rivet pin? Is it counter? Which one is the answer? Oh, it's not flat. That I know for sure. Flat should be this way, like this. You know what a flat object is now? The snap head should be like this. Flat should be this way. Do you get it now? It's not flat. Is it countersunk? Countersunk should look this way. Anytime you are a countersunk, it should look this way. It's not countersunk. It is between snap head and rivet and mushroom head. So it might be confusing because snap head and mushroom head almost look alike. Let me show you the picture here. So if you look at snap head and mushroom head in this picture now, you will see it You can see flat edge. This is flat edge here. This is flat edge in this place. Yeah. And this is countersunk. Yeah, you can see countersunk. But if you look at snaphead and mushroom, they look almost alike. If you are not careful, you will not know the answer. Here it is what? It is mushroom. So take note of the difference between snaphead and mushroom head, so you don't get confused. So the answer here is what? Is mushroom head with a head pin. 33. The type of key most appropriate for tapered shaft is what? Is option A, Woodruff key. It's always Woodruff key for tapers most appropriate. The best to use is Woodruff key. 34. The construction of a spiral staircase is an application of what? Remember what I explained earlier on. A spiral staircase is going to have a pillar in the form of a circular pillar like this, in the form of a cylinder, and a curve goes around it like this as the staircase. So what type of curve is this? So this is a 3D curve, like I always explain. This is a 3D curve, and that will be what? That will be helix. That will be helix. 35. The type of locking device shown in figure 22 is called what? It's called this locking device. There are different types of locking devices that we use in mechanical drawing with our fasteners, so that to keep them in place. So go and look at it. This type exactly is known as the tap washer. It's known as the tap washer. We move on to question number 36. Oh, this is a very interesting question. This is electrical part. It's an electrical part. Yes, 36. The symbol shown in figure 23 represent a what? Represent, oh, it's not a fuse. It's not a fuse. That's not a symbol for a fuse. It's not a capacitor. A variable inductor is not an inductor. Variable, anywhere you see variable, you must see what? You must see this arrow. When they put this arrow on any symbol, any convention for electrical component, this sign means is the variable of that component. If there is no sign like this, that means that it is the fixed of that component. So the symbol for resistor is this. Convention for resistor is this. Do you get it now? So if they have showed you only this is a fixed resistor. This should be fixed like this. Do you get it now? But the moment they put an arrow to it, makes it what? A variable resistor. So the answer is what? Variable. What's the difference between fixed and variable? Fixed means that the fixed value of this resistor could be 10 ohms. Do you get it now? Could be 10 ohms. But if it is a variable resistor, it will not be fixed. The value will not be fixed. The value will not be fixed. Value will not be fixed. It will not be a fixed 10 ohms. They might give you maybe 10 to 15 ohms. Do you get it now? So it's it varies. Do you get it now? Depending on the current you are trying to pass through the component. The sketches in figure 24 show mechanical tools. Very good. Mechanical tools. Use them to answer question 37 and 38. So the first thing you should ask yourself is, what are the names of these tools? Then you try to find out what they are used for. So which of the tools are used for marking out? Marking out. Marking out. So this is what? This is a tri-square. Tri-square is used for marking out. Tri-square is used for marking out. This is a what? This is a caliper. or divider. Do you get it now? Then this is a scriber. Do you get it? So what is used for, which one is used for marking out here? It is B. We use a tri-square and a scriber for marking out. Tri-square can check the squareness. Do you get it now? The squareness of a metal sheet, while scriber is used for writing, scribbling on it. Do you get it now? Scribing. So the answer is 1 and 3. Then 38. Which of the tool is used for transferring measurement? That is what? That is a caliper. We use it for transferring measurement. Caliper. So 39. The cutting plane shown in figure 25 indicates what? See, we have a cutting plane. Can you see it now? So if you look at this, this is sectioning. What type of sectioning is this? You can tell us. This is offset sectioning. That's the type of sectioning. Can you see it now? They start from here. Do you get it now? It did not go fully. Do you get it now? It doesn't go half like this. It doesn't stop there. It comes. So offset sectioning is used to show specific parts that they want to show the interior feature of that component. So they want to see the interior feature of this component of some specific part. So that is an offset section. So how many cutting plane is being used? That's what they're asking us. So you can see this is, I'll show you, this is look at it. This is one plane and this is another plane. That's 1, 2. Do you see it now? So that is A, sectioning in 2 planes. Sectioning in 2 planes. Assuming it goes entirely. Let me show you. Assuming it goes entirely like this across, that will be one plane. Can you see it now? If it goes like this, maybe in 3 places, goes, maybe they show us like this, like this, like this, like this, like this. Do you get it now? Something like that. That will be 3 planes. Do you get it now? But there is nothing like a right angle plane. Right angle, no. There is no sectioning at right angle. If it's a right angle, maybe they will tell you that is half sectioning. Do you get it now? So 1 plane, 2 plane, 3 plane, like that. So this is what? This is two planes. That is 2 planes. So the last question for this paper, says the thread profile shown in figure 26 is dash. The thread profile shown in 26 is that. This is very simple. They brought a very simple thread profile. Just look at the mouth, the edge of the thread. Look at it. What shape do you have there? What shape? Let me complete it for you. Maybe you will get it. This is it. If I complete it like this, it's something like that. Is the shape coming out? What shape is that? It is a square thread. It's a square thread. Thank you for watching my video. Don't forget to like, to subscribe, and to turn off your notification button, and also share it with your friends so that they can also learn and we can all excel together. Remember, technical drawing made easy. Thank you.